Well, here's the idea. We're going to make a linearization of y prime equals f of xy by finding the equation of this tangent line. Then we're going to bump x0 over a little bit and use this tangent line to approximate the function, and then find ourselves a new tangent line, and then we'll bump x0 over another little bit. That little bit, by the way, if it moves from enough of those little bits, it'll get all the way over to x1, wherever x1 is. So we let h be that little bit that we're going to move it. That's kind of familiar with you for calculus class, I guess, also.
That'd be fantastic.
Yeah, I hope you get the idea. So anyway, on the linearization function, we have y1 equal the linearization at x1, which is y prime at x0 times x minus x0 plus y0. That goes back to here, but solved for y. So that's an approximation to the value of the solution to y prime equals f of xy at, well, this one we already know, but when we move x to x0 plus h and call that x1, then we can write y1 is y prime at x0 times h plus y0. Remember, h is this x1 minus x0. So that gives us a way to approximate y when x is changed by moving h units from x sub 0. And we can express that as y1 equals h times f of x0 y0. Remember why we can say it's that? Because that's our derivative, right? At x0, remember our function, dy dx equals f of xy. So that is our derivative times this h plus y0. So the point x1, y1 is on the graph of the linearization of the function, not necessarily on the graph of the function, but it's a point on the graph of the line we use to approximate the function. And that gives us an approximation for the y value of the unknown function when x equals x sub 1. X sub 1 being 1 h past x sub 0. Right? And how accurate our prediction will be based on how big is your h. Because if we use this line to predict with an h value from here to here, well, this line isn't going to be a very good predictor for this function right here. What we're going to wind up doing is make a lot of small h's in between and kind of move along tangent lines until we get close to what the actual number is. So I hope you're getting it.
Suck it up.
If not, suck it up.